Our next speaker comes from Israel, and he will be talking about repeated inflammation insult mediated by neuromodulation and neuroproliferation are fundamental to the development of vulvodynia in an animal model. So, please.
Hi everyone. I know it's a hard time for everyone after the lunch, but I'm promising it will be a very interesting presentation. First, my name is Awad-Igbaria. I'm a PhD student at the Chronic Pain Laboratory. I'm working under the supervision of Professor Jacob Ponston and Dr. Paltzur. Today I'll talk about the development of provoked vulvodynia in a rat model. First, multiple studies suggest that there is a correlation between repeated inflammation and the development of provoked vulvodynia. Several animal models have been developed to investigate this correlation, and the result of this paper led us to the initial inflammatory theory. The suggested mechanism of this theory that there is a primary trigger, for example, candida, that causes inflammation, and during inflammation there is a robust increase in the inflammatory agents that contribute to the development of provoked vulvodynia. In the current study, we aim to investigate this mechanism. To be more precise, we aim to investigate the development of persistent vulvar hypersensitivity in a rat model of provoked vulvodynia developed after 3 rounds of inflammation challenge. So when it comes to the method, what have we done before the inflammation challenge? We measured vulvar hypersensitivity with an electronic von Frey device to determine the baseline of vulvar sensitivity. In the current study, we use zymosan to achieve inflammatory response. Zymosan is the yeast cell wall, and it's widely used in inflammation and pain research. The zymosan was injected in the vulva 3 times, as you can see here, 7 days between each injection. And to the control group, we inject saline, also 3 times, 7 days between each injection. Vulvar sensitivity was measured 2 and 5 days after each inflammation challenge, and after the 3rd zymosan injection was measured every 20 days. In addition, in day 158, we performed the elevated plus MACE test to examine the anxiety levels of the animals. So let's move on to the result. First, here we demonstrate that only in the inflammation challenged group there was a significant decrease in mechanical sensitivity. As you see here in the zymosan group is in the red line, and we found that in comparison to the control group, the reduction in the reduction in mechanical sensitivity of the zymosan group was maintained for 5 months after the inflammation challenge. In figure B, you notice the frequencies of the rat that developed chronic vulvar pain. The cutoff if the rat had a vulvodynia or not is defined at 30% reduction in mechanical sensitivity compared to the baseline, and is based on a previous animal research, and we found in the current model approximately 90% of the rat that were injected with zymosan developed chronic vulvar pain. Together, the current results suggest that repeated inflammation in the vulva led to a long-lasting vulvar hypersensitivity in animal model. In further analysis, after 4 months of the inflammation challenge, after 5 months of the inflammation challenge, we performed elevated plus MACE test to examine the anxiety level of the animals. If the animals feel high level of anxiety, it will spend more times in the closed arms and less time in the open arms. Since the closed arms are considered as a safe environment. As can see in figure A, we found that the zymosan groups spend more time in the closed arms and less time in the open arms compared to the control group, and the calculation of the anxiety index indicates that the zymosan group express high level of anxiety compared to the control group. Furthermore, we also detect a correlation between the reduction or between the mechanical sensitivity and the anxiety index of the allogeneic group. Together, these results suggest that chronic vulvar pain in animal model causes anxiety. to the molecular aspect, hyperinnervation and mast cell accumulation are the two most consistent features of provoked vulvodynia. Here we use a neuronal marker, PGP 9.5, to examine the sensory hyperinnervation at 2 time points after the inflammation challenge, after 20 and after 160 days. In green, you see the neuronal marker. We found that at the 2 time points, there was a significant increase in the density of the nerve fiber in the vulva among the zymosan challenged group. 1 minute? Okay. And in the zymosan group, the nerve fiber were located near to the epithelial surface. Furthermore, we also assessed the expression of the pain channel, TRPV1, which is responsible for heat and burning sensation, and the TRPA1, which is responsible for cold and mechanical sensation. And we found after 5 months, there was a significant increase in the expression of these both pain channels in the vulva after the inflammation challenge. I will move on to the main result about mast cell. Mast cell, there is a substantial body of evidence suggests that mast cells are involved in the development process of provoked vulvodynia. Here we examined the accumulation of mast cell after 20 days, and we found a significant increase in the number and the activation of mast cell after 20 days with the inflammation challenge. And surprisingly, after 5 months, also we found a significant increase in the number of mast cells in the zymosan group. Together, I have to highlight a critical point of the current study. First, we found that the zymosan challenge rat developed chronic vulvar hypersensitivity that lasting approximately 4 or 5 months after the inflammation challenge. We also observed anxiety-like behaviors in the allodenic rats, the zymosan group compared to the saline group. We also found that during inflammation, I didn't present that here, but we found a significant increase in the nerve growth factor that playing a critical role in the nerve growth in the zymosan group compared to the saline group. This our proposed model for the development of provoked vulvodynia, that there is inflammation that induces mast cell activation and increase in NGF and glutamate, and these two pathways signaling lead to hyperinnervation and to neuromodulation. Thank you. On time.
We have time for one question.
Thank you. Great presentation. Obviously, I wish you had more time to present. So the idea behind inflammation, and particularly yeast exposure, we know that that only a small proportion, probably, of women who are exposed to yeast or these types of inflammatory events go on to actually develop vulvodynia. And so the question is, and I think your pathogenic mechanism is correct and probably is what happens. But if we look further upstream, why are there a certain proportion of women that when they are challenged with yeast or other inflammatory events, that they are the ones that go on to develop vulvodynia, as opposed to others who are also exposed but don't? Do you have any theory? I have theories, but do you have any theories about why that is?
It's a very interesting question, but if you take each factor separately, it will not be conclusive. But if you put them together, it will be much clearer. So when we're talking about inflammation, we talk about the frequencies and the duration of the inflammation. So if we high level of frequencies of the inflammation, it will lead more and more will contribute more to the development process. So I think also I think also there is a genetic predisposition and the hormonal imbalance, and there's a lot of factors that are involved in contribution to the development of provoked vulvodynia. It's not only one factor that is inflammation.
Thank you.